So we'll move to the water sector examples, and as I said, I have the window open and I hear a little bit of a wind rustling sound in the podcast, but I will let you live with it because I have to live without an air conditioning in Mumbai, which is not always easy. Okay, so let's suffer together for the sake of reducing our own impacts or our carbon footprint. So table 2, renewable energy solutions for adaptation in the water sector. I'm reading these because the details are important, and as we said, adaptation is very region specific, local specific, sector specific, sometimes culture specific, economy specific, and so on. So we have to read just to get a sense of these things. So looking again at climate impacts like water scarcity, increased water pollution and contamination, flood, drought, disruptions, and look at adaptation needs in terms of stable freshwater supply that's needed, water resource management that's critical, water quality enhancement, wastewater treatment and recycling, which often become a big problem, like the Queensland flood, I think in 2010 blew out their wastewater treatment center, which they hadn't imagined. It was such a massive storm and flood, and it took years to rebuild. And places like DC, which are right on the edge of the water in terms of where they place their wastewater treatment, are sitting there. Sea level is rising, storms are coming up, so they're highly vulnerable. But here we are talking about renewable energy for adaptation in the water sector. Also includes flood control needs and drainage, water conveyance and distribution. So energy related measures in that sense are desalination, distillation, groundwater or aquifer pumping. You can see I'm reading them together because I want you to get a sense of the needs, impacts and the energy related measures, and you can match one on one if you want. But these are examples, not really comprehensive or exhaustive in any way. Okay. Water purification and sanitation. Water purification and sanitation. Wastewater, sewage and sludge treatment. Water distribution and drainage control, with renewable energy solutions ranging from renewable energy systems to power underground pumping, renewable energy systems to power desalination plants. Non-energy services include hydro dam to increase water reservoir capacity to deal with emergencies like water scarcity, floating photovoltaics to reduce evaporation. There are other issues with dams. There is the methane emission issue and silting issues, downstream impacts on ecosystems and people, and so on and so forth. So it's a question of cost benefit and whether more people are being benefited than being harmed, not always taking care of the biodiversity, etc., of course. So here floating photovoltaics to reduce evaporation is another non-energy service, which is a very easy one. Actually, if you have canals where evaporative losses are high and you put solar panels on top, you reduce direct evaporative losses. Quite straightforward solution for that. Renewable energy systems to power water clearing pumps, remote and small scale water purification through renewable energy systems to deal with water pollution and contamination issues. And there are energy plus non-energy services like biogas plant for wastewater treatment and recycling. Non-energy service includes hydro dam to control flooding. Of course, in Delhi in July, in India in 2023, dam release from one state ended up flooding Delhi because of, there are safety issues involved. If you don't release water from a dam, the dam may break down and so on. So sufficient warning has to be given to the people who will receive the floods, but you cannot always avoid it. Okay. So solar or wind pumping as well. Continuing with renewable energy solutions, we have reductions in crops and cattle production to deal with, and food supply chain impact caused by high temperature that have to be dealt with adaptation needs to stresses such as water and heat stresses, salinity and new pests as temperatures and rainfall patterns, etc. change. Number of reduced frost days or cold days means increased pests and expanded latitudinal range of pests and so on. Enhance flood production, food production, sorry, not flood production. Animal health and disease control, food processing, storage, distribution and sales help will be needed in terms of adaptation. Food utilization, so food nutrient, food safety enhancement. Okay, energy related measures for these adaptation needs: air cooling systems for indoor and outdoor systems, water spray for cooling, and soil fertilizers. Cooling, chilling, freezing, drying, pasteurization, cooking, fuel supply, and so on. Renewable energy solutions can be such as clean cooling, renewable energy systems to power groundwater pumping, agricultural waste fertilizer, non-energy services like agroforestry, mixed farming with perennial energy crops. So agroforestry is where you're basically mixing trees with crops, and this is actually this is how humans started as agricultural modern humans, but along the way we started expanding agriculture and production so much because population also kept growing that we started to become, clear out land just for agriculture, which reduced increased evaporative losses and reduced soil moisture persistence, groundwater recharge, soil carbon, and so on. So energy solutions can serve agroforestry as well as mixed farming with perennial energy crop. You can read the details on how energy is used for those, but these are non-energy services served by renewable energy solutions. Renewable energy based food freezers, refrigerators and storage, renewable energy based food dryers or pasteurizers, renewable energy based clean cooking solution. And we also have, in terms of impacts, climate extreme events, reduction in fisheries production, water scarcity, which is indirectly related in this case. We looked at direct effects already. With adaptation needs including food system stability enhancement, fishery resource management and conservation, water supply for agricultural use, and the energy related measures including early warnings for preemptive crop protection. This is my favorite. We always need to convert weather forecasts with increasing skills to early warnings for food, energy, water, health, transportation, and everything else. Greenhouse fuel supply for fishing ships, groundwater or aquifer pumping and irrigation. Sorry, the wind is a bit strong. Climate information service powered by renewable energy. Oops, a little too strong maybe. Let me close the window there. Okay, sorry about that. I will make sure that sound is not too bad. Okay, so let's go back into the display mode and pull up the pointer. And so climate early warnings, fuel supply and groundwater. The renewable energy solutions are climate information service provided by renewable energy based greenhouse horticulture and vertical farming, which is very good for urban areas, for example. Non-energy services include fisheries and aquaculture in offshore wind farm, marine protection areas around offshore wind farms. So these are kind of co-benefits of renewable energy solutions in a non-energy service mode. Renewable energy systems for groundwater pumping. So energy plus non-energy service here is used as an example, agro photovoltaics. Okay. Maybe continue with table 4. Yes, let's finish this here. Renewable energy solutions for adaptation in natural disaster response, another sector. Since adaptation is very sectoral, we will read these even if it takes time. Okay. Climate impacts include life and health loss caused by climate catastrophe like flood and extreme winds. Life and health loss caused by climate catastrophe such as heat waves, migration, displacement and relocation, sometimes forced relocation, energy system disruption caused by extreme weather events, with adaptation needs ranging from risk reduction and preparation against climate hazards to disaster response and recovery, emergency health services, protection and preparation for hazards, disaster response and recovery, mobility through timely resource efficient resettlement support, climate resilient energy system. Okay, energy related measures, early warning systems again, great, quick recovery infrastructure, communication network power supply, air conditioning, freezing and chilling, ventilators, generation and distribution of electricity in emergency settlements, energy system recovery and reconstruction, and the renewable energy solutions that meet these adaptation needs in terms of energy-related measures are weather forecasting and early warning systems for natural disasters, so off-grid meteorological stations powered by renewables, etc. Renewable energy for lighting and emergency housing, off-grid renewable energy for infrastructure fixes and communication. Secondly, energy plus non-energy services include hydro dam, renewable energy-based active cooling systems, freezers and chillers powered by renewable energy, off-grid renewable energy generation in disaster-hit regions, off-grid renewable energy for infrastructure fixes and communication, in this case of migration, displacement and relocation. Renewable energy for lighting and emergency housing and decentralized energy systems. So some repetition, but they fit into different climate impact alleviation here. Okay, so we'll come back and read some focus message on making renewable energy technologies ready for climate change. Scalability is a big issue, so we are relying on technological promises of deploying renewables. We've talked about finances and how they have improved, how COVID helped deployment of renewables, how Russian invasion of Ukraine affected gas supplies, and Europe ramped up some of its renewable energy deployment and so on. But we will come back and see some other aspects of the same thing in this context of renewable energy synergized for adaptation services. Okay.